All right, welcome. Your briefing for Task 2 is now underway. We're about to embark on a pretty critical mission to get inside the mind of a nuclear reactor. Our goal here is to break down how these incredibly powerful machines work, but to do it safely and clearly. Think of me as your health and safety officer for this explainer. Let's get to it.
So, here's our mission plan. First, we'll get cleaner on the task itself. Then we'll dive into Part A, the diagram. After that, we'll tackle Part B, the explanation, and then Part C, which is all about forming an opinion. We'll wrap things up with a final safety check. Simple as that. So, let's talk about this mission of yours. It's all about getting a solid understanding of how a nuclear reactor actually works. And look, this isn't just some abstract theory. This is about you grasping the powerful science that's really shaping our planet's energy future. My role here is pretty straightforward. I'm here to make sure everything is absolutely crystal clear. You see, in the world of nuclear energy, there is zero room for confusion. Because clarity is safety. So let's keep that in mind as we move forward. Our whole mission breaks down neatly into 3 parts. First, you're going to draw the reactor. That's how we'll learn its components. Then, you'll explain the whole process from start to finish. And finally, you'll form an opinion on a more advanced kind of reactor. Let's take them on one by one. Okay, let's get into our first objective, deconstructing the machine itself. Now, I know it can look complicated from the outside, but don't worry. We're just going to focus on the 5 most critical parts. Here they are, the only 5 key parts you need to worry about. For each one, the job it does is pretty simple. The fuel rods, they just hold the uranium. The moderator, it keeps the reaction going steady. The control rods, think of them as the brakes. They control the speed. The coolant keeps everything from overheating. And finally, the turbine is the part that actually generates the power. Nailing these 5 parts is your first step to success. And listen up, this is a crucial piece of intel. You do not need to be an artist. Seriously, what we care about is accuracy. A simple, clear diagram that shows you get the parts and what they do, that's the goal. In this line of work, precision always beats a pretty picture. Okay, so we've identified the key parts. Mission objective 1 is complete. Now let's move on. We're going to explain how all those parts work together in a perfect sequence to turn tiny little atoms into a massive amount of electricity. You know, it's really easy to get lost in all the technical jargon, but the main idea is actually surprisingly simple. At its heart, a nuclear reactor is basically just a giant, really powerful kettle. That's it. It's all about using a process called nuclear fission to boil water and make steam. Now, to explain this clearly, I want you to imagine you're explaining it to a 12-year-old. A simple 4-step story is the best way to do it. You'll start your sentence with, first, inside the reactor, and then you just follow the logic, from heat to steam to the spinning turbine, and then finally to electricity. If you use that structure, first, then, next, finally, the whole thing becomes super easy to understand. All right, we've covered the fundamentals. Now let's get into something a little more complex, a little more controversial. We're going to talk about a special kind of reactor. This is where you move from just knowing the science to actually forming a solid evidence-based opinion about it. So first off, what in the world are we even talking about? A breeder reactor is a nuclear reactor that, and get this, actually creates more fuel than it uses. I know, it sounds like it defies logic, but it's a fascinating piece of technology, and the science behind it is absolutely real. So if they're so great, why are these things so controversial? Well, this slide cuts right to the chase. When you create more fuel, a byproduct is something called plutonium-239. And while, yes, it's a powerful source of energy, it also happens to be a key ingredient for nuclear weapons. It's this dual-use potential that makes it such a hot-button issue all around the globe. Okay, to handle a sensitive topic like this, you need a rock-solid structure for your argument. Now, I'm not here to tell you what to think, but I am going to show you how to think. Start by stating your position, for or against, nice and clear. Then, back it up with 2 separate reasons and make sure they're supported by evidence. Finally, just wrap it all up with a short conclusion. And here's the most important part when you're evaluating this technology. There is no single right answer. What really matters is the strength of your argument. It doesn't matter if you're for or against breeder reactors. The key is to build your case on solid evidence and clear, logical thinking. We are approaching the end of our briefing. So before we sign off, let's run one last final safety check, just to make sure all systems are a go and that you are fully prepared to complete your mission successfully.
So here it is, our final check. We've covered the 3 key deliverables: a simple diagram, a clear step-by-step explanation, and a solid framework for building your opinion. With these tools in your pocket, your mission to understand nuclear reactors is officially complete.
So, you get the machine now, you understand the mechanics, but let's end with a bigger question. The UAE has a very bold plan, net zero by 2050. How does this machine, the one you just drew and explained, help us get there? That's the real reason we need to understand this stuff. It's something to think about. Mission accomplished.